Hi everyone, today we're going to calculate the heat of reactions, or enthalpy, which is delta H. Alright, so just to review, enthalpy is the heat content of a substance. Remember, heat is kind of synonymous with energy. So we like to measure how energy, or enthalpy, changes. So that's what the delta stands for, change in heat. Okay. We can calculate the change in heat by using this formula. Delta H equals the heat of our products minus the heat of our reactants. And so what does delta H tell us? Well, delta H tells us if it's positive, that the reaction will be endothermic. And if we get a negative delta H, a negative number, then it tells us that a reaction is exothermic. Okay, so the heat of a reaction, is it gaining energy, endothermic, or is it losing energy, exothermic? So we're going to need a thermodynamic table to figure out the delta H here. Fortunately, you don't have to look at this table. If you were in my normal class, you would, but this year's a little different, so I'll do things a little different, a little easier for you all. So I'm going to simplify the table when we do these problems, so you don't have to strain your eyes so much when you do these. So when you look at this table, though, what do you notice about pure elements like hydrogen and bromine here? So you should notice that the delta H is equal to 0 for any element. Okay, any element by itself. The delta H is 0. So delta HF stands for the heat of formation. So how much energy is needed to form these chemicals? And because elements are found in nature, it takes no energy at all to form these chemicals. And that's why we get 0. Okay, let's do a practice problem or example problem together here. It says here, using a table, determine the enthalpy, so that's delta H, for the following reaction using this formula. So again, it's total products minus total reactants. And we've got a table on the right to help us out. And we've got a chemical equation up here to look at. So the way I'm going to do it is I'm going to write the products, total products. So I have 2 HBRs. This is my products. Remember, products are on the right side of the arrow, minus my total reactants. I've got H2 plus bromine. Next, I'm going to use my table on the right here to plug in numbers now. So now I've got 2 times negative 36.2. Okay, that whole thing minus, well, I'm lucky here, all of these are just zeros. 0 plus 0. So I calculate this and I get negative 72.4 kilojoules. Okay, so in this reaction, if I have a negative delta H, you want to write down what does that mean? Well, that tells me the reaction is exothermic. And that's how you do these problems. Just to recap it here, what we did was we took our chemical reaction up top, and we're trying to figure out the heat of this reaction. So we took the total products, 2 HBRs, and then we subtracted the total reactants, H2 plus Br2. Remember, if there are coefficients, we should include them. And that's exactly what we did. We multiplied 2 times negative 36.2, and we got this negative 72.4 kilojoules. That tells me how much energy is being released from this reaction, right? The heat of this reaction. And because it's a negative number, I know that it is exothermic. All right, let's do one more, this time using a few more numbers here. So the process is the same. We're going to take total products minus the total reactants. So I'm going to use brackets. It's going to help me separate the two. So I've got 2 waters and a carbon dioxide. So let's just write the elements first. So the total is going to be 2 waters and carbon dioxide. Remember, products go first, and then we subtract the reactants. CH4, I have 1 of those. And I've got two oxygens here. Oops, sorry. I meant to put CH4 here. Next, we're going to plug in our numbers. So I have two waters. Each water has a value of negative 242. So there's going to be a lot of number crunching here. Plus, carbon dioxide is negative 393.5. So all of that is my products. And then from that, I'm going to subtract CH4, which is negative 74.8, plus oxygen, which is 2 times 0. All right, now we got to simplify our numbers. Be careful with your negatives, okay? So plus minus here. This is going to give me a really big negative number for my products. Minus, I've got a negative 74.8 here when I simplify it. So if I do minus a negative, I'm actually adding these numbers together. And I get a delta H of negative 802.7 kilojoules. And then you want to ask yourself, is this endo or exothermic? And because it's a negative number, this is exothermic. All right, so again, just to recap, we took the total products and then we subtracted the total reactants from that. I like to put the element symbols first, and then I go back and then I substitute the element symbols with the numbers. I calculate or crunch the numbers to get my final delta H, my heat of my reaction. So this chemical reaction is a combustion reaction. Makes sense that it is releasing heat, that it's exothermic.